here we are in the last topic for chapter 5, which is electron affinities. Okay, so from the last video, if we have ionization energy, which is the energy required to remove an electron affinity is the energy change when an electron is added to a gaseous atom to form a -1 ion. So electron affinity, for example, we have fluorine atom or gaseous fluorine atom. If this fluorine atom is, or if an electron is added to this fluorine atom, so it will gain a -1 charge, so it will become a fluoride ion, and the energy involved for this is called the electron affinity. So electron affinities can be negatively charged or positively charged. It depends on whether the atom will accept readily an electron or not. So as you try to recall, if we have the groups 5A, 6A, and 7A, so they readily acquire electrons to become stable, while for groups 1A, 2A, and 3A, they give off electrons. So that means they are hard. The groups 1A, 2A, and 3A elements are harder to give electrons, or they are the electrons are harder to add in those elements. Okay. So also, noble gases have positive electron affinities. So why is that? So noble gases, they have complete valence electrons. They have fully filled orbitals. Therefore, if we will add additional electron, it will be on the next main energy level, which is farther with respect to the nucleus. Okay. So this neon, for example, has a positive electron affinity. Okay, so let's take a look at this table. Okay, so as you can see, there is no trend, honestly, in the electron affinity. Okay, for example, we have this second period. So the lithium is -60, and then for beryllium we have +50. And then the boron will become -27, carbon -122. Okay, so what happens across a period? Okay, so in the beryllium, or in this column, as well as in the column of the nitrogen, okay, so this part first, in the beryllium, magnesium, calcium, and strontium. Okay, they mostly have positive electron affinity, because if we add another electron, it will go to the 2p orbital. So 2p orbital having singly filled, so that is not that stable. Okay, since we have an additional, or we have an addition of atomic orbital. So what is more stable is that we have the fully filled orbital. So for example, in beryllium we have 2s2. For magnesium we have the 3s2, and then this 3p orbitals are not filled. Okay. But if we take a look at the lithium and beryllium, so lithium has -60. So meaning it will acquire that additional electron easily. So why is that? If the lithium, okay, for example, this one, so this one has the valence configuration 2s1. So after gaining an additional electron, the valence electron will be 2s2. And take note, 2s2 is fully filled. So it is more stable than a singly filled 2s orbital. Okay, same with sodium and potassium and rubidium. So they will acquire easily the added electron to become to make the s orbital fully filled. Okay. So going to the 3A or group 3A, so this has is still negatively charged or still negative values for electron affinity, but this time it is lower. Okay, since after adding an additional electron, the added electron will be just on the second atomic orbital, which is empty, and it will still have another one empty atomic orbital. In group 4A, so group 4A, so this has the valence electrons 2p or 2s2, for example in carbon 2s2 2p2. So the additional electron will completely fill the atomic orbitals as singly filled, and this singly filled atomic orbitals is more stable than the carbon atom only having two singly filled and one with no electron. Okay. So as we go take a look at this electron affinities across a period, we do not have a general trend. Okay. So simply to say, we do not have a trend for across a period. But down the group, we have a periodic trend for this electron affinities. Okay, so as we can see down the group, this is becoming less negative. Okay, so this when we say less negative, this means that the electrons or the added electrons will repel, or which will, so these added electrons will more likely repel in the nucleus. Okay, so this means that the electron affinities become larger, or when we say electron affinities, they will have larger values. So negative 73 is smaller than negative 47. Okay, so that was it for electron affinities. So I hope you understand in this electron affinities that we do not have a trend on the across a period, but down the group we have. That's it.